Alright, so let's say Prof gives you a physics problem. So he says that, alright, we're on top of the Empire State Building and we're dropping pennies on the people below. Alright, on the people on the street. So he says, alright, come up with a function that models velocity as a function of time. So you think, alright, this is pretty easy. We can use standard kinematic equations. V is equal to V naught plus AT, right? Find velocity before dropping it, right? Initial velocity in the y direction is 0, acceleration just negative 9.81, 1t, and v is equal to negative 9.81 t. Right? Easy, right? Easy peasy, lemon squeezy. Drop pennies, accelerated negative 9.1 meters per second squared, so velocity is a function of time, negative 9.81 t. Alright, so that's your final answer, you circulate all that. Then Prof comes up to you and he's like, alright, I never said that you could neglect air resistance though. At that point, you crash out. Because you don't know how to deal with air resistance. But Prof decides to help you out because he says that, alright, I'll help you out a little bit. We're going to say that the force of drag, right, the force of the air resistance is proportional to velocity, right? Proportional to the velocity of the falling penny. So we can say the force of drag is equal to some kV, right? So we're still lost, but let's not become lost. So let's walk through this. So this is useless now. So let's just draw a free body diagram of whatever's going on in the penny. So let's see here. We drop the penny off the Empire State Building. So we have penny, right? The force is acting on it. We got the force of gravity pulling down on it. So I'll put W, call this one W equals mg, right? But now, we don't just have the force of gravity. We got the force of air resistance pulling up on it. So we're going to have some force of drag, right? And that's equal to kV, right? kV in the opposite direction, right? It's like the counter force. We'll define downwards as positive, upwards as negative, right? So let's think about this. Maybe come up with the F net equation, just trying to see what happens. So let's see here. So net force, right? F net. Let's see, it's going to be equal to mg, right? mg minus kV, right? kV is like the counter force, so put that negative sign up there. So yeah, F net is equal to mg minus kV. Makes sense so far, right? Just the weight minus drag, force of gravity minus force of drag, right? Drag is going in the opposite direction. So let's see here. F net equals mg minus kV. Okay, F net. All right. Well, we know that F equals ma, right? So maybe we'll just like put in a ma. That does not look like an a at all. Maybe we can put in a ma. Right? Ma is equal to mg minus kV, right? Maybe solve for a right about here. So maybe say that a is equal to mg minus kV over m. All right. Cool. But let's see here. Prof initially said that we want to find velocity as a function of time, right? That models the velocity of the penny, like over time as it's falling onto an unsuspecting person on the street. So let's see. We have a though, right? We don't have time anywhere. We only have acceleration. So I guess we could rewrite acceleration like in terms of velocity because we know that a is equal to dv over dt, right? So we could say that dv over dt is equal to mg minus kv over m, right? So I think that's one thing we can do, right? And if you notice, we got differential equation right here. And this is actually great because if we solve this differential equation for v, we'll get v as a function of time. And that's exactly what Prof is asking us for. So I think I'm going to stop here for right now because the first biggest screw up is going to happen while trying to get to this equation. Next biggest screw up is trying to solve the equation. Yeah, that's like complicated. But hopefully you understand this. It's basically simple Newton's laws and stuff like that. It's just like force adding and stuff. Mg minus kV, like that should make sense. And a is dv by dt, so that should make sense. Deriving the differential equation, pretty easy. Solving it, not so much. So, follow for more things like this, where next video we actually solve this thingy. So yeah, pretty cool.